Okay, let's suppose you have three different sets, A, B, and C, and we want to find various, set operations and set relationships on these. So in part A, we want to find A intersect B together in parentheses, and then union C. How I recommend doing these is to do them by steps just like you would math problems where you work kind of from the inside out, like your order of operations. So do your parentheses first. So the first thing I would do here is I would figure out what is in A intersect B. So what is in both A and B? And I'm going to write this in the braces. So as I look at the different elements in A and in B, I see that the elements 1 and 6 are the elements that A and B share. So I want to union that now with set C. Union means or, so it means to keep anything that's in this new A intersect B set that we've got, or in C. So I'm just going to start with the 1 and the 6 since they're definitely in there. And now I'm going to add into this additionally anything that's in C that I haven't listed yet. So I haven't listed yet -2. I have already listed 6, but I haven't listed 9 or 12. So that ends up being my final solution. You kind of do it in steps. The next one wants us to take A intersect and then take B union C in parentheses. So if you notice, A and part B are the same. They are all say A intersect B union C, but the parentheses have changed. Now we know that the associative property works where we can do them in any order we want, but so far, or what we were shown with these associative rules, is that it only works if the symbols are all the same. It only works if they're all unions or if they're all intersections. So what we're sort of trying to see right now is, does it work as well? Can we just move the parentheses if we have two different symbols going on? So we're going to see, is that the case? So again, on this one, we would start by doing B union C. So let's keep any elements that are in B or in C. So I'm going to just start with B. The elements in B are -4, 2, 1, 6, 9. And then let's keep anything also that's in C that we haven't listed yet. So we haven't listed yet -2. We already listed 6 and 9, but not 12. So we need to put that in there. Okay, so here's our B union C. Now we need to intersect that with A. So what is in both A and in this new set? So if I scroll across there, I see, okay, a -2 is in both of those sets. A 1 is in both of those sets. And 6 is in both of those sets. And that is it. So what we can see by doing these two problems is that the associative property does not hold if we have two different symbols. Okay, so you can't just do those in any order that you so choose. It makes a difference. When you do have parentheses, when you have grouping symbols in these operations, always do those grouping symbols first, just like you would in your algebra. Okay. Next problem says, consider the following data from a survey of students in a college. So it says 244 students were taking a business course. I'm going to call that B. 208 were taking a math course, M. 152 were taking economics. 72 were taking business and mathematics, so that would be B intersect M. 46 were taking business and economics, so that would be B intersect E. 60 were taking courses in math and economics, so M intersect E. 24 were taking business, math, and economics, so the intersection of all of them, B intersect M intersect E. And 150 were not taking a course in business, math, or economics. They were not taking those. So this would be like the parentheses B or union, M union E, close it up, the complement of that. So that many people were not taking any of those. First, we want to draw a Venn diagram to illustrate this information, and then we want to answer some questions. So my tip to you is anytime you're doing this, again, you want to basically work from the bottom up. You want to work from the most specific information that you have out by subtracting. So the very bottom one is a very specific place. If 150 students were not taking courses in business, math, or economics, they weren't taking any of these courses, then they would be the ones completely outside of all of the circles. Sorry about that. They would be the ones out in this universe, like they go to the college, but they were surveyed, but they weren't taking any of these. So 150 kind of out in that rectangle, not in any circle. And so I've checked off this layer. 24 were taking courses in business, math, and economics. So where do all of those circles overlap? Like that very center little chunk is where 24 students lie. And now here's where you have to be careful. It says 60 students were taking courses in math and economics. So I need to find where M and E overlap. So there's this crescent where they overlap. And what this is telling me is that 60 total students belong in there. But I can't just put a 60 here, because now I actually have 84 students in that area, right? There's already 24 students in there, so I can't do that. So here's where the subtraction comes in. We need to say there's 60 total students in there, subtract, we already have 24 accounted for. So there are actually 36 students in this next slice. I'm going to check that off. It says 46 students were in business and economics. So we need 46 total students in the overlap of B and E, but we already have 24 in there. So we subtract that off, and it looks like 22 total students would fit in this next slice then. 72 were taking business and math. So if we look at the B and M slice, we need 72 total people in there, but 24 are already in there. So when we subtract, we get 48. Okay, so now we're told that 152 students were taking economics. So we need 152 students total in the E circle. So I'm going to start with 152. But in the E circle, we already have 22, 24, and 36 students. So we have to subtract all of those off. And that would leave us with 70 to go out here just in the part with the E that's not overlapping anything else. Okay, 208 students are in the math circle total. But in the math circle, we already have 48, 24, and 36 students. So we need to subtract those all off. And doing that leaves you with 100 to be just out in the M area, not overlapping anything else. And finally, we need 244 students total in the B circle for business. But we have to subtract off the 48, 24, and 22 already in there. And that ends up being 150 left in just the B part. Once you work your way up like that, then you can answer any question. You should be able to answer any question they might ask. So let's see. It says, now determine the number of students taking a business course who are not taking a course in either math or economics. So these are students only taking business, not also taking math or economics. So that's how that would be this only in the B part that's not overlapping anything else. So we've already really done that work. Now we can just read it off the chart. That should be 150 students. How many students are taking a course in exactly 2 of the 3 disciplines? So where do we have exactly 2 overlapping? I can look at here and I can see there are 48 students who are taking just business and math, but not economics, right? So those 48 students count. They're taking exactly 2. And then we can see that it's all those kind of like secondary crescents. There are 36 students who are taking math and economics, but not business. And there are 22 students taking business and economics, but not taking math. So if we add all those up, that's 106 students. And then to find the number of students surveyed, we just need to add up every single number everywhere in the diagram. So we've got 150 on the total outside. And then our larger areas, we have 150, 170. And then working my way in, it looks like we've got 22, 24, 36, and 24. And when you do it this way, you're not double counting anyone. Like each one of those represents a single person. And adding all of that up gives you 600. So there were 600 total students. So you can kind of go back and see that if you don't take the time to do it this way, you could be wrong. I bet a lot of students would initially maybe they would just add these numbers up, and that would not give us 600. Or maybe they would add those numbers and also the 150, and that still wouldn't get it right. You really have to break it down to every one of these little pieces of your diagram in order to make sure you're not double counting anybody.